Welcome to a new test and teardown video. This time we are going to talk about my tube measurement unit here. It's called an AVO VCM 163. I think it's actually a quite famous unit. It is from 1966. It is made in Dover, England, and AVO moved to Dover in 1966, and the year after they were joined with another company. So that is why we know that this unit is from exactly 1966, because of the name and Dover. I believe that is true, but if you know anything better than that, please tell me if this is a fact or not. So of course I want to show you a little bit what this unit is and what I got here, by the way, because I got, I think, the complete unit with a full box of 10 adapter sockets, and those adapter sockets you can fit in almost any kind of special tube. There's a whole section about all this and how this is done, and then you just plug any of these adapter sockets into the international. It actually doesn't really matter where you plug it, because it only fits here, but the trick is that all those 8 pins here, they go to those 8 pins here, and then this unit can be configured in any special way you want. Of course, you can just make your own if that is the case. I will explain more about that in a minute. So that was the whole box of all my adapter sockets. I even got the original plastic cover, and if I fold this out, it's actually more or less complete. There's a little hole here that was fixed with some tape, but other than that, it is quite all right. It even smells old. Anyway, so this unit is quite old, like I said, and the manual is up here. There's a metal holder. It's supposed to be the other way around, where it fits a little bit better, but since this manual is this old, you can see it was used a million gazillion times, and it starts, of course, with the pin out for the standard numbering of the different valve sockets. I think today I'm only going to play with the Novel socket, the B9A. And what is important to note is the direction of numbering, and also that they're viewed from underside of socket. That is, of course, if you take the tube and look into the bottom of the tube, this is how you normally look at the sockets. And it also talks a little bit about the socket adapters. We got a lot of different socket adapters, and they explains also in the manual how this is set up. All those funny socket adapters. And then the whole idea is you look up your tubes and then you figure out the settings. I am going to cover how to use this unit in another video. This one is actually only going to be the hardware and how this unit is designed, how it is made, and what it is. And so that is why I will not cover usage in this video. So please look at the other one if that is what you came for. So let's start to look at the top sockets. So we got all those different sockets for all the different tubes. They also say in the manual that some of those sockets are not always mounted and that's because they went more or less on obtainium, as they say in the manual. So then if you have a more recent unit or some of the later manufactured units, you could actually have a blank instead of a socket for some of the more special or more rare sockets. But the thing is that all those sockets, they're just connected in parallel. So pin 1 is connected to pin 1, to pin 1, and so on, right? All pin 1s are connected together, and then they go here. It even says here, this is pin 1. Well, it doesn't really say pin, but you need to know that, right? So all those are the pins in all the sockets in parallel, right? So far, so good. So we also got top connection 1 and top connection 2. So those are also your options. And of course, that is the top connection 2 and top connection 1. So if you have a tube with a top connector, it's most likely an anode, but it can actually be screen and other things really, but it's mostly anode. So you connect this top electrode to the top of your tube, right? And then you of course select that feature with that connector. So here is the settings for all the different pins, and that will be the different features. If you disconnect all the pins, so if you dial all these to 0, you can take an ohm meter and measure pin 1 to pin 1, pin 1, and so on, and you will find 0 ohms. That proves that all those sockets are connected exactly like I said, and then they are of course completely disconnected from the rest of the unit. Of course, if you connect them to the rest of the unit, you're not going to measure 0 ohms because the unit is at the moment powered off. I really think it is a good idea to have it powered off when you're playing around with the connections, just for your own safety. I really take good care of this unit not to screw around with it because it's high voltage and stuff like that. I don't want to break it. So what is it? It is 4 power supplies, 4 variable power supplies, more or less most of it really. So grid voltage is a negative voltage, and you can set the grid voltage in 4 ranges: 0 to 3, to 10, to 30, and to 100, and then it's dialed in quite correctly with this, and it is a DC negative voltage. That's all there is to this, and this is done with resistors. So there's a negative voltage and just resistor dividers, because this is a high impedance output voltage. So far so good. Screen voltage and anode voltage, they are made by all those tappings on a transformer and then rectified to a DC positive voltage. So that is why they are of course the same voltages. That's because it's the same tappings on that transformer, and then they go to their individual DC voltages. At the moment I'm not using screen voltage, that's mostly for pentodes. I'm mostly playing around with triodes, so I don't need screen voltage, so I just have it as low as I can. Anode voltage I of course need, and most likely for small signal triodes I just use 250 volts, but anyway, that could of course be different for whatever use you wanna. So this is that will be the 3 DC voltages. Then we got the heater voltage. Heater voltage is AC volts, and it is also made by tappings on the transformer. In fact, all those outputs That's also tappings on the transformer. So you can imagine this is a very, very special transformer with all those outputs. And then those and those and those, right? So this is 0.1. This is 1 volt, and then this 10 volt per step here, right? So you can imagine a heater that's running at 110. Wow, that is something, right? So that is our AC heater voltage. So here is our measurement and function setup, and here we got the set, and this is for the AC mains. This is actually how you calibrate the unit, so that all the voltages and gains and stuff like that is going to be accurate. At the moment, it's actually done by just putting it right here and just dial in 230 perfectly correctly, and then just set the readout. Oh, maybe I should turn this off to that exact point. We could probably just turn it on and see that this is happening. So here's your input voltage calibration, and that is of course important when all this is done by tapping on the transformer, right? Imagine different voltages here. It's gonna affect everything, right? Simply adjust. So you can see here, we are now adjusting the drive on that transformer. I can of course also just adjust my mains, but because I got a vario on the input here. This unit is using 7 watts. It only consists of 6 transistors, so it's quite modern of its time, not containing any tubes. I think it's a little bit wrong to do it like that because it's testing tubes, so why couldn't it have been tube based? But that's just how it is, right? So this is the different leakage selectors. So this will we can just go here, and then we should see, of course, no leakage. So it's an ohm meter, and we can just go through the different connections, and there's of course nothing to see because we don't have anything connected. We don't have a tube connected, so we should of course see no leakage. So now we're back to mains voltage. But you can also apply heater. So now we are applying the 6.3 volt AC to the configured pins in that socket that we want to use. And in this case, we have heater is there's actually a little bit funny how they've done this, but they talk about a heater positive and a heater negative. So it's a little bit stupid because it's not AC, it's not DC, right? But this is, the positive is just one end of the heater, and the negative is the other end of that heater voltage. So don't think that this is a positive or this is a negative. It's just the opposite end of that AC winding. And of course, in this case, we're playing around with ECC 81s today. So we want on pin 4 and on pin 5, we want to short those. So that is pin, or this is feature number 2, okay, connected to pin 4 and pin 5. So they just have those numbers. Those numbers mean nothing really. It's that little text down here that is indeed the feature. Those numbers are just here to make it easy to look this up or put all these settings in a table. That's all it does. This pin, this number 2 here is nothing like a pin or a connection. And don't be confused about that. It's only 4 and 5 here, right? That's important. Then the other end of the heater on an ECC 81 is pin number 9, and then it is selected here, feature number 3, the other end of the heater. What you can actually do is do it the other way around. Put those two filament windings in series and apply 12 volts. This is your choice. You can do that. This is not how it's done in the manual. This is the recommended settings from the manual. But feel free to do that. If you like to do that, you can do that. It's your own problem, right? So that is just a little basic setup here. I didn't really want to talk so much about that in this video, but I think it was important to understand that now we have applied heater. So when we have applied heater, there will be, of course, a leakage to heater. Don't you think so? No, there is not. And that is because there's no current flowing between those. Aha, that is actually interesting. Normally I think I see this, but I think that's because normally I have a tube connected to it. And so then with the heater connected, you'll of course heat up the tube and it's going to change its behavior. And then you can actually see some leakage on some defect tubes. So this is the idea is you do this. Then all the rest of the settings, that's also still with heater voltage applied. Then this is cathode to heater isolation. So it's actually explained here in mega ohms. So you don't want to see anything here. And then you go to test. So now comes the fun thing. In test mode. For an ECC81, what I've set this up right now, it will now apply an AC signal into your control grids. So there's a 2 volt DC voltage, a negative DC voltage, but there will now be a very weak AC voltage from an oscillator applied to the grid. And that AC volt will of course be gained to the anode, and then the anode AC will be amplified and read out on the display, and this is your gain. So that is how it works, and you can change between the 2 different anodes, and then you'll read your 2 different gains if it's a dual triode. So that is the main functions. It also has a gas. I believe that what it's doing here, it's actually changing the bias, and then it's measuring if there is any leakage current. So that means if there is a leaked gas into the tube, you could probably see a current. So in this case, you should of course see nothing on the meter. Of course, we will see nothing because we didn't mount a tube. So that is what is inside this beautiful unit, seen from the front, of course. That is all it consists of. I think we should try and open it and look at the internal stuff. The right side of the unit reveals the oscillator and some of the alignments. The top one here is for calibration, and that potentiometer you can access through the side. All you have to do is remove this little dummy blanking, that one, and then you'll be able to access the calibration alignment. So the oscillator is actually really nicely done with transistors and all that kind of stuff. And then inside this piece of aluminium, we got 2 temperature sensitive resistors. I don't know if I can, let me go. Yes, look at that. So that is how it's how they're connected together thermally. So yeah, and down here is the amplifier. We can't really see a lot. That will be the test switch. Oh, look at that. And that is the Enigma. It looks a little bit like an Enigma, right? With all those switches coupled to all sorts of features. It's really beautifully and intelligent designed switch. Maybe I can show you this. All the different wires from the different sockets just go like this all the way around, and they're of course connected in parallel, and then they go to each of the individual switches. Now let's try and open it a little bit more. Due to this really nice shape of the design, as you can see here, it is completely protected. All the switches and stuff is completely protected because of this side here, so you can easily put it on the front like this. So here is the rear panel taken away, so I need to hold it with one hand to lift it so we can see what's going on here. So this is of course the bottom side of the top panel with all the tube sockets, and you can easily see they're nicely color coded and going from socket to socket. Super nice. I really like the way this is done. And here is the center to each of the switches, and this is the connections to the features of this unit. And this little metal stick that you see here, all those sticks, they kind of go all the way through. It's actually possible to film this if I go a little bit down here. Yes, here you can see it. So those, they actually go all the way through all the switches. And I think that is a very cute way to make those switches. But of course it's impossible to find a replacement switch or to even recreate what they're doing here in a smaller or more compact way. Very special stuff. And if you desolder all those points here, they didn't even add a switch. No, they just soldered those connections. But if you push down here and just solder, tick, then you will disconnect all those all those connection points, and then you can take away the entire top unit and perform service on it. This way you can take it out on your table and rewire stuff or replace a socket and stuff like that, because it's a little bit annoying to crawl around in here. Yeah, I should probably show you those transformers with all the million outputs. Those are really nice too. Look at all those multi-deck switches. Nice. I give up taking away the bottom cover because it's really stuck somehow. But I can show you the transformers and all the multi tappings. Somebody wrote okay on that one. They're just really big and heavy duty. I actually don't know why they are this big and beefy, because it doesn't really need to be. They don't need to be this big because of the power, but they're specially made for low impedance to keep all the voltages very nice and steady and regulated no matter what you do, because there isn't really any feedback from the output voltage. So that is how it's done, by just using really big transformers. So we got some capacitors that's changed, and that one is not looking like it has been changed, or maybe it has. Oh, we got some resistors, some secret notes in here, as always, those permanent markers. Oh, by the way, here's the fuse, and this is the main entry fuse, and you move this to the correct socket for a voltage input selection, and that is why you see only one fuse and that many different positions. You access this through that side, but there isn't really any reason for me to go in here and have a look. But I think that is what I wanted to show you about this unit On the inside, here is the amplifier. It's driving the gain meter. We got diodes here for protection of that meter, and that is the overload protection relay, because of course you can have a short circuit, or you can also connect stuff wrong, and then you need some sort of a protection so you don't blow up this wonderful old unit. So feel free to go and have a look at my next video that will show how we use this instrument. There's actually one more thing I really wanted to show you, and that's just those classic permanent marker handwritten notes you find all over places. My father loved to add those notes. I think it's mostly for himself, so he's not going to figure out stuff again and again. And this one up here is really interesting as well. I think this is also his handwriting, and it was recapped quite some years ago. But that's a lot of fun to find all those notes.